All right, class, so now I want to talk about using p-values to reject or not reject our null hypothesis when our standard deviation is unknown. So let's take a look at a couple examples. So first off, p-values can be found in Excel, and they'll be automatically calculated for you. You can also find a range of p-values for a given problem using table A-3. So using table A-3, that's our t-table, right? We're going to assume a sample size of 14. That means my degree of freedom is 13 because I take n minus 1, and that's going to be my degrees of freedom. Oops. Let's assume we have a right-tailed test with a test statistic of 1.93. So look at table A-3 in row 13, the degrees of freedom, and you will see that t equals 1.93 is between these two values. Now, look at the top of the page for the area in one tail, and you'll see that you are between area of 0.025 and 0.05. Hence, the p-values for this test would need to be between these two values. And so you would reject at the 0.05 level, but fail to reject at the 0.01 level because the 0.01 level is all the way over here, right? It's even less than that. Now, let's assume we have a sample size of 14. So the degrees of freedom is 13. And we calculated a left-tailed test with test statistic negative 2.94. You're going to drop the negative sign, okay, because we're looking at t-tests. We aren't measuring standard deviations above and below the mean. You're going to look at table A3 in row 13. That's our degrees of freedom for this t-value. And you will see that it's between two values. So what you're looking for when you go into the t-value, if you're going to use p-values, is you're looking to find the two values it's between. You're going to look at the top of the page, and it shows you the area in one tail, and you're going to see that you are between an area of 0.005 and 0.01. So the p-value for this test would be between these two values. So you'd be able to reject it at the 0.01 level, but also the 0.05 level, because 0.05 is greater than this. Let's take another look. So assume we have a sample size of 14 again, so my degree of freedom is 13, and I have a two-tailed test, okay? My test statistic that I calculated is 2.46. So again, I go to table I go to our t-table, I go to row 13, and I look for this value. Now you're not gonna have that value exactly. You're gonna see two values it's between. So it's below 2.650, and above 2.160. So then you have to look at the top of the page for the tails option, and you'll see that you're between an area of 0.02 and 0.05. So the p-value for the test would be between these two values. And hence you would reject at the 0.05 level, but not at the 0.01 level, because 0.01 is less than your interval. So let's look at a problem that we saw in the last video, but using the p-value method now. So I am looking at a significance level of 0.01 to test the claim that my mean is greater than 9.7. So that means my null hypothesis is that my mean is equal to 9.7, and my alternate hypothesis is that my mean is less than 9.27. My sample size is size 10, so that means my degrees of freedom is going to be 9. My sample mean is 874, and my sample standard deviation is 57.3. So we're going to go ahead and calculate our t statistic like we did last time. Okay? We got a test statistic of 2.922. So we drop the negative, we go to our table, we go to row 9 because that's our degree of freedom, and we look for two values where our t-score fits in between. We're going to see that this score we found is between the t-values of 2.829 and 3.250. So the p-value is between an area of 0.005 and 0.01. So because p is less than 0.01, we do not reject the null hypothesis. We do reject the null hypothesis, right? We want our p-value to be less than our significance level, alpha. Let's take a look at this example again. So, for each of the 12 organizers, we said 12 scores have a mean of 2,133, a standard deviation of 345, and at the 0.01 significance level, okay, we want to test the claim of a stock doctor who complains that the mean for all such organizations exceeds, so is greater than, 1,800 per client. With this information, we have our sample size, our level of significance, our sample mean, our sample standard deviation, our null hypothesis that there's no difference, right? Remember, it's always going to have an equal sign, and our alternate hypothesis that the value exceeds, so is greater than, $1,800. We use this information to calculate our t-score. We get a t-score of 3.34. Now, my sample size was 12, so my degrees of freedom is going to be 11. We go to our t-table, we go down to row 11, and we want to look for two values that would encase 3.34. We see that our t is greater than 3.106, which is related to the area 0.005. And because our p-value would then be less than that, our p-value is less than alpha, so we do reject our null hypothesis. Let's also take a look at how we could use confidence intervals to solve this problem. So for a two-tailed problem with a 0.05 significance level, we would want to construct a 95% confidence level. Okay, that's our area and our two tails. Or if we have a nice little drawing, 0.95 is here, 0.025 is on either tail. For a one-tail problem, we would want to construct a 90% confidence interval, right? Because we originally had 0.05 in our one tail only, and that would leave us with an area of 0.90 in the middle. Remember, an area under a normal curve is 1. So we have our example, right, with the 12 organizers, and the cost per operation per client is found. We have our sample mean, sample standard deviation, size of 12, our significance level, and our population mean. So we're going to construct a 98% confidence interval. Remember, we have 0.01 inside one tail only, so we must multiply that by 2. So here we have our confidence interval. We'd have 0.98 on here, 0.01 on either tail. So we would look for the critical value for an area and two tails, and we would get 2.718. Remember, we only need a positive value for the confidence interval. I would go ahead and calculate my error bound, okay? So now I'm 98% confident that the true population mean lies within the above interval. Hence, we do continue to reject the null hypothesis just as before, because the true population mean of 1,800 is not in this interval. And if you have any questions about how to calculate confidence intervals, you're going to want to take a peek at Chapter 7 videos.